Okay, that seems to be working. Right, so hello everyone and welcome to Coffee and Code. With us today for the second time is Phil Ewels from the NGI. And yeah, since this is your second talk here, I will just hand over to you directly. So welcome, Phil.
Thanks very much, Sarah. Yeah, no, it's nice to see everyone again virtually. Just a fun little talk today about regular expressions. Maybe for some of you will be a bit of a refresher. For some people, it might be new stuff, and hopefully it's useful for everybody. I'm trying to keep an eye on the Slack and YouTube out of the corner of my eye. So this would be nice if this was fairly informal. So if you have any questions, just ping there and I'll try and keep an eye and answer to stuff as I go along. But without any further ado, I will just kind of crack on. So, right, regexes, regular expressions. Regular expressions are a core feature of most coding languages. I don't think I'm aware of really any coding languages where it's impossible to do a regular expression. As a result, I'm trying to keep basically all of this talk agnostic to programming language. The rules are pretty much the same everywhere. There's some like slight differences in how you actually specify different things. So if in doubt, I'm kind of erring towards the Perl kind of notation. But generally, these are kind of pretty broad concepts which apply to most languages. So a regular expression, before I go on, I know that sometimes Zoom presentations can be a bit dry, especially ones on topics like this. So if you remember nothing else from this whole talk, just remember this URL. I'll mention it more at the end and maybe do a quick demo, but I think it's fantastic. I never do any work with regexes without using it. So check it out. Also, I should say that regular expressions, which is shortened to regex or regex or regex. There's been a bit of discussion about this on Slack and on Twitter before this talk about how different people pronounce it. I've always called them regexes. I make no apologies for that. I'm sorry if it offends you. And I don't think it really matters. Anyway, regular expressions or regex. So regexes have a bit of a sort of bad name. On the Trello board for Coffee and Code, under the suggestion for this talk was this comic. It's quite a good Twitter feed, so I recommend checking it out. And it's definitely kind of true that regular expressions, when you see them in the wild, can look like a mess, basically. And it can be quite intimidating to kind of get in and figure out what's going on and do any debugging, especially. And when you come to write them, things can get a bit complicated quite quickly. But if you keep things simple, remember the basics, and kind of work through them step by step, then almost anything's possible. So we're going to start off with just some basics here. I'm going to go through like kind of the core concepts of regular expressions, how you write them, and some of the main operators. So at the core of regular expressions, they are basically just a way to specify a pattern and search some text with that. That's all it is, really. So if you look on Wikipedia for regular expression, the introduction paragraph tells you that it's basically a sequence of characters that define a search pattern. And maybe we want to see if we have a bunch of sentences like this, and we want to see if the word regex comes up in them or not. So we write a regular expression that looks like this. We have the 2 forward slashes. This is like the Perl notation for doing a regular expression, but it's very common. And everything in between those 2 forward slashes is the actual search pattern. And here it's just regular letters, just regex. And unsurprisingly, that matches the 2 places in this paragraph which say regex. As you'd expect, if we add a P on, now it only recognizes that second one, regex, and no longer matches the first match. So this is just very, very basic stuff. But what happens if you want to match both of those and the full string? That first example missed off the P on the second one. Then we can add what's called a quantifier to one of the characters. So the letter P now has the question mark, which quantifies that there must be at least 0 or 1 P's, letter P's. And now that applies to both of these instances of text, and we match both full string of both regex and regex. We can kind of get a bit crazy with this, of course, and start putting more and more question marks in and making our expression more flexible so it matches more things. It's not terribly legible, but you can kind of see the logic here. And this is pretty much how the rest of regular expressions go. You kind of just expand and make things more or less flexible. But there must be nicer ways to do this. Of course there is. You don't want to have to just write out these massive kind of optional strings. So we can use different types of quantifiers and different types of matching classes. So I mentioned the question mark that says 0 or 1 of that character or that class. There's also star that does 0 or more, plus which does 1 or more. And then if you use little squiggly brackets, you can start to define specific numbers of matches. So if you use one digit, exactly that digit, or if you use a comma, then you can sort of specify a range. Hopefully that makes sense. We can also start to use square brackets, which is a character range. So here, the first square bracket says A to Z, and there's also a space character in there. And the second square brackets matches A to Z. So that matches any lowercase letter, A to Z. The stars mean 0 or more matches. And so now that massive long string search pattern is much shorter and much more flexible, and we still get the same matches out of it. That's good. So character classes can have pretty much anything in. You can put a series of letters in there, and it will match any one of those letters. And of course, if you have a quantifier after the character class, then it will match any one of those letters as many times as you specify. The dash here is specifically for ranges of characters. So you can have A to Z, lowercase, uppercase, and you can have 0 to 9, for example. And you can also put some other kind of clever stuff in there. One of the things you can put in is a modifier at the start of a character class, which is this little hat character. And that says you can matches anything except for whatever follows it within the character class. So the top one matches either A or B or C. The second one matches any character that's not A or B or C. And the third one matches anything that's A to Z. Writing A to Z lowercase, A to Z higher case, 0 to 9, hyphen, underscore, again and again and again, every time you just want to match like an alphanumeric character is kind of tiresome. The same with writing white space, where you don't care whether it's a space or a tab. So regular expressions have these kind of meta characters, which are basically just shortcuts to those character classes. So here's pretty much exactly the same match again, but now we say reg followed by /w, which is like a word character, so A to Z, 0 to 9, /s, which is white space, where we can have 0 or 1 white space, and then another one for any word character. And again, it matches exactly the same things, but now this is a bit faster to write. And as you become more familiar with regular expressions, they're actually kind of easier to read like this as well, in my opinion. So there's quite a few of these different meta characters, but the main ones that you'll bump into on a regular basis are probably W, S, and D, which are word characters, white space, and digits or number. And importantly, with any of these meta character shortcuts, if you make them uppercase, it negates that character class. So it's the same as putting that little hat into the square brackets. If you do /T, you have anything that's not a number. If you have capital S, anything that's not white space, and so on. Okay, the dot is kind of a special type of meta character and deserves mention itself. And the dot just matches basically anything, specifically anything that's not a new line character here. So here I've said reg followed by any character which is not a new line as many times, between 0 and more times. And so it hits that first reg and it just goes on to the end of the line. Assuming that we actually have new lines in this string. Except sometimes it also matches new lines. I'll come on to that a bit later on. But basically the dot matches anything, so dot star just will match your entire string. Sometimes you want to anchor your patterns to a particular part of the string. So when we searched for regex, or it just looked anywhere within the search pattern for that match. If I searched for just /w, I would get a match for every single word character in this string. But by adding this little hat character again, now we're outside of a character class. This is just in the main regular expression. If I add that little character as the first character in the the search pattern, then that anchors what follows it to the start of the string. So in this case, we only get one match now, and it just matches the first word character if it's at the start of a string, which it is, which is a capital A. Hopefully that makes sense. There's a few of these. Again, there's the three ones that you're likely to see are hats at the start, a dollar symbol right at the end of the search pattern, which anchors it to the end of the string. And you can use /b, which is another special meta character, which means just anchors that part to any word boundary, which means kind of the start or the end of a word. So you can see how all of these special characters take our original kind of search pattern string and start to kind of make it more specific or make it apply in different kind of edge cases, which is, again, how regular expressions work. Sometimes you might want to match one or another thing, especially within the middle of a pattern. And here we can use the pipe character, which just is like a Boolean or, if you like. So here we have the pattern says reg or exp, and it matches both of those strings. So you can see we have, what's that, 6 different matches, all the regs and all the exps. Hopefully fairly clear. This isn't so useful in like this when it's just like an entire regex, but you can put that inside brackets. Brackets are used to make what's called a group within a regular expression. And here you can see, now we're matching RE followed by either GU or SS. And that's then the whole match. So we get regu and res. So you're matching GU or S. And that group allows us to kind of break up this logic of optional matches. Groups are actually really key to using regular expressions, because so far we've only talked about just matching a string, which is one of the main ways you use a regular expression. You say, is this pattern matched or not in a given string? But by using groups like this, you can also start to pull out specific parts of matches. These character classes for here, so here it doesn't make any sense because we probably know that it's GU or SS, so it's not so interesting to return that. But if we were using a meta character which matched a range of characters, we might not know what that actual string characters looked like, and a group allows us to pull this back as a result into our code. What happens if you want to use one of these special characters though? Like it's actually in your text. You can escape it just like many other things within code. So if I want to use a regular bracket because I want to match it in the text, I just escape it with a backslash, and then it behaves like a regular character. The same is true for question marks or stars or full stops, anything like that. You can always escape them with a backslash. Sorry, maybe I'm going a bit quicker. Okay, that was the basics. Hopefully everyone's still with me. I haven't put everyone to sleep because I'm either going too fast or too slow. So if all of that made sense to you, you should now be able to write a pretty basic regular expression to match basically any kind of pattern within text. What else can we do? One of the things which makes these quantifiers kind of a bit more powerful is you can change a little bit in the way that they work, in the way that the regular expression matching works under the hood. So here we've got star, which is matching 0 or more matches, you can see. And you might think, why did I have both white space and a word character here, /w and /s? Why not just use a dot star to match anything between reg and x? And would that not give the same result? But you can see here it doesn't, because dot star matches everything. And the dot star is by default greedy in a regular expression. So it finds what's happening here on that top line is it finds reg, and then it finds dot star, which just matches to the end of the line, and it's happy basically. So it just kind of runs off and matches the whole thing, which is maybe not what you would have expected. So yeah, just to be clear, this is treating the whole thing as a single line this time, and it goes from the reg to the exp, if that makes sense. So of course you can control this. This is a greedy quantifier by default, but we can make it non-greedy by adding, or lazy, by adding a question mark after it. Now, star question mark is its own quantifier. This is like a little unit there. So Again, question mark's doing lots of stuff here, but just think star question mark is its own quantifier. And now we're saying that it should be a lazy quantifier, should match 0 or more things, but as few as possible instead of as many matches as possible. And now we get the expected result where it just goes regular expression instead of going all the way through to that last regex. Any comments? Someone pointed out /w also includes underscores, yeah, and hyphens, I think, as well. And there's some other dialects of regular expressions. So, okay, these are really good points. Keep them coming. This is good. Sometimes it's a hassle, especially if you want it always to be ungreedy by default. You don't want to have to stick in a question mark every single time you use a star character. So what you can do in most languages is you can do what's called a modifier to your regular expression, which is basically a way of changing the default behavior of the regex engine. So here, if this is Perl, after the end of the /, we could put a capital U, and that makes all of the modifiers, all of the quantifiers, sorry, in the regular expression ungreedy by default. So now the star, just by itself, is a lazy quantifier, and we get the same behavior as before. Just like the others. So yeah, just like the other things we've discussed, there's a whole bunch of these different modifiers that you can use in regular expressions. U is just one of them. I've actually been using G for basically all of the examples so far, which would make the regular expression global. Without this, it would just find one match for regex and then just stop and wouldn't return any of the others. But adding the G means it keeps searching. It keeps trying to find as many as it can. Adding a lowercase I at the end makes it case insensitive. And adding a lowercase m means that the anchors, instead of matching the entire string, now kind of respect new lines in your string and actually search every single string one at a time. So they match the start to the end of each line instead of a whole string. And this, and then lowercase s kind of sort of does the opposite, basically. It forces it in the other direction. So I said that dot matches everything except for new lines, but if you have S, it kind of treats those new line characters as regular characters, if you like. So then dot just matches everything. So dot star really will match like the entire thing, irrespective of how many lines you have in your variable. Okay, this is one of the things that does vary quite a lot in syntaxes between different languages. So if you're writing in Python or I don't know, different languages, you'll probably have these same modifiers available to you, but you might well have to kind of specify them as variables in function calls or things like this. And so just bear that in mind. It might not look quite the same, but the same thing should exist in concept. So I mentioned these groups, which can kind of bring together the logic of certain matches and also return results. And groups also have a whole bunch of modifiers to change how they work, and you can do special things with groups. And this is one of the things that, in my experience, does vary sometimes slightly between different languages. Just the raw group like we have here is basically the same everywhere. That's very standard. But some of the more advanced tools ahead may not be available depending. So just bear that in mind. So here, our basic one here, we're getting 3 matches from this group, GU, SS, and SS. Maybe we want to use a group to have logic for the OR operator, GU or SS, but we don't actually want to return those as matches. We want a group, we don't want to have a matched group. In that case, we can stick question mark colon at the start of the group. That's where group modifiers go. And that makes it a non-capturing group. It behaves in exactly the same way. It's just if you're fetching the matches afterwards, you won't see this particular group. Maybe that doesn't really matter. If you only want to detect whether a string's there or not, you might not actually be looking at the matches which are returned, so you might well not need this. So this isn't maybe the most useful example, but to pick a different one here, you could have 2 groups. So we've got a first group which is matching 1 or more digits, 0 to 9, in a character class. I could have done -/d here as well. And then we've got a second group there, which is matching the suffixes, so first, second, and so on. But that second group is a non-capturing group. And this just makes it a bit easier for our downstream parsing because the matches come back as just the numbers without the string at the end. but we still have the power of that second group, which only specifies those numbers on the first line and not the second line because they don't have the suffix. Okay, hopefully that makes sense. This talk is very meta. It's quite difficult to make it visual, but hopefully the syntax highlighting and stuff here is making sense, and everyone's hopefully following along with this logic. So non-capturing groups, not something you need to use a lot, but occasionally useful and makes your downstream code a bit easier to handle. I just thought of another thing here, which I don't think I've put into the talk, but some languages have what are called named capture groups, which is when you use kind of greater than, less than symbols at the start of the group. And then you can put whatever text you like in there. And then the language will return that specific match for that group as a named variable. So if I wanted to catch this numeric suffix, I could put in the name of that second group as suffix, and then my matches would come back, and I could address that by a named variable. Especially if you have very long regular expressions, this can really make the downstream analysis much easier and a bit more flexible, because you don't have to refer to each of those matches by the array index. So if you add in another group in the middle, it doesn't mess up all your code because you've got named variables. That's another type of group modifier, which is only available in some languages, though. Something a bit more complex with groups is what's called look-aheads. So here we've got our very first regular expression from the talk. We've got regex, and it's matching in two places. It's just got the word regex, but also part of the word regex. So what if we only wanted to match that first one, regex, but not regex? That would, with everything I've said so far, that would be very difficult because it's not anchored to the end of a sentence. I could maybe specify that it has to be followed by a white space character or something, but it's kind of difficult. But sometimes you find yourself in this situation. One of the ways you can deal with it is what's called a look ahead. So this is another special type of group. So we've got the question mark at the start of the parentheses there. And this time that's followed by an exclamation mark, which says it's a negative look ahead. So now the regular expression engine finds regex, but then it keeps going and looks for the contents of that those brackets and looks for the letter P. And because it's a negative look ahead, if it finds that P, then it invalidates the match. So this now does what we want it to do. We find that first word regex, but not regex. And this is a simple example with just the letter P, but of course you can imagine you can start to apply quite a complex logic here to get exactly the matches that you want. Yeah, so because it matches that P, then that invalidates the match. If you want to do the opposite, you can switch that exclamation mark for an equal sign, and then that becomes a positive look ahead, and it just inverts the logic. So now we only get a match if that bracket is there, but it's not actually really part of the regular expression, if that makes sense. So you can see that in the yellow, the regular expression isn't matching the P, but it only matches if the P is there, which is a subtle difference, but sometimes important. Something I also, as I'm giving this talk, I'm kind of noticing all the stuff that I've forgotten to mention. I talked about groups doing, if I had made this just a regular group that I could kind of pull out the different matches that it finds. But one of the things that regular expressions are classically used to do is to do substitutions. And so it's very, very common to see with the regular expression languages to do kind of find and replace. And then you can, again, refer to these groups as named variables typically. So kind of $1 would be the first group, $2 would be the second group, and so on. But that's pretty simple, hopefully. And right at the very end, I was going to do a quick live demo, and I can show that in action. Okay, so that is the end of my kind of tutorial of pretty much everything I know about regular expressions, about how to write them, and about kind of how they work. When you write that, all of that will be kind of compiled into a byte string and under the hood. And then, for example, if you're using Python, then that is passed off to, like, I think C underneath. So these things are usually done on a pretty low level and are pretty quick. And usually a fairly core part of many languages, especially ones like Perl. It's quite difficult to write Perl without regular expressions. That's a groovy. Okay, so that wasn't so bad. So what can cause confusion? These are kind of the classic things that trip people up when they're writing regular expressions. the most obvious one is when you forget to escape a special character. So here I've got, I want to match the S at the end of that first line. So I do S dot because I want to match the S and then the full stop. But of course, dot matches any character that's not a new line. So we actually have a whole bunch of matches here. We have S everything, which is not really what I intended when I wrote this. So this can cause really unexpected effects, and is just something you always need to remember, that we've got to remember what these special characters are. And if necessary, you need to put a backslash there to escape it. So now we're escaping the full stop to just a regular character, and we get the match that we expect. Unexpected greediness is one of the ones that's a bit harder to kind of guess in advance, and is probably the thing that trips me up the most these days. So here I'm matching A, then anything, then A again. I think you can probably see that maybe I've highlighted it. No, I didn't. There's an A in can and an A in dangerous, but it skips that dangerous A altogether and goes straight ahead to the third one because it's being as greedy as it possibly can. And the biggest match it can do is kind of spanning those 3 A's. So that's what you get returned. And again, that can be kind of unexpected and do weird stuff sometimes. So again, just by sticking in the lazy modifier here to the star, we get the match that we're expecting. Unexpected emptiness. This is quite a subtle one. So I've got a regular expression on the left here, and I've got some text on the right. You can see that I'm using a group with 2 options, and you can see that neither of those strings are anywhere in our target string on the right-hand side. So as expected, there's no yellow here. We haven't matched any text within the string. However, what's quite subtle is that the star is 0 or more matches. And we got 0 matches. So the regular expression engine will return a Boolean true if you're searching for whether there's a match or not. So even though there's no match, string match, you still have a regex match, which can really mess with your code. So, and this is one that can really make you scratch your head for a long time because it's basically invisible to see. So again, remember, don't use star if you don't have to. If you really expect this thing to be there, use plus to make it 1 or more matches instead of 0 or more matches. And now this behaves as we'd expect. It returns false, so there's no match in this string. One of the things that always trips me up, especially if I haven't done any regular expressions for a while, is that lots of these characters do lots of things. You've probably picked up on this already in this talk, but I've talked about question marks doing at least 3 different things. I've talked about the hat symbol doing at least 2 different things. So it's quite hard sometimes to remember, okay, is it star question mark? What is question mark doing something different here? And again, there's not really any easy way to get around this. You just have to kind of practice, I guess, with regular expressions. And over time, you start to kind of remember what all the different things do within the different contexts. That if you have a hat at the start of a regular expression, it's different to if you have a hat within a character class. It's a bit tricky. It's just the way it is, but it trips people up a lot, trips me up a lot. So just kind of bear that in mind. Something else that can be quite subtle, this is Andreas suggested this on Slack, is the difference between different regular expressions. And this can be really so the underlying regular expression engines that are powering your regex search. And this can be really, really infuriating because you can write a regular expression, test it, it works beautifully. And then you try it in a different language, or you try it on a different system or something like this, and it doesn't work. And you can't work out why it's working on one system but not the other. Andreas gave me that link to Stack Exchange, which gives a really nice kind of longer description of this. But the core thing to know here is that there are more than one different underlying kind of logic or engines to regular expression matching, which have got not very catchy acronyms, but there's the basic one, and it's extended, and then there's Perl compatible extended, PCRE. Different languages use different flavors. You might even be able to switch between different flavors and stuff. Most of the stuff I've talked about is available in all of them. There's a few of the more advanced stuff which may only be available in some. So just kind of bear that in mind. This is one of the reasons for using egrep instead of grep. You can or grep minus E on the command line. Right, we're getting there. So that's how to write a regular expression. That's how to, some of the things that cause me difficulties on a regular basis. And now kind of finish up with a few top tips or little kind of nuggets of advice and things to think about when you're writing regular expressions to hopefully help you on your way. Just Google it. I think this probably, I found this meme on the web when I was poking around trying to find memes to end the talk on a light note, and it kind of resonated with me. I think it's true for many people who write code that if you just Google it, you can find a regular expression for like most things. Stack Exchange is full of questions about regular expressions. So if you need to match an email address, it's probably not worth scratching your head over it. Just Google it and you can copy and paste it and check it works. So it's definitely cheating, but yeah, that's what most people do. All right, I mentioned this at the start. Use regex101.com. Here's a little screenshot of it in action. It's a website. There's lots of websites like it, but this is by far my favorite. And basically, I just think it's kind of wonderful. I built a lot of this talk with it. And I'm just going to switch to Chrome, where I'm going to kind of demo this very fast for you. So this is the website here. Hopefully you can all see that. And you can see at the top, I've got my regular expression, which I've written. I can choose the different underlying engine that I mentioned before. So by default, it's PCRE, the Perl version. And I could put in a test string underneath. It highlights all the matches here. If I hover, it tells me about it. It says it's match number 1. And on the right-hand side, it gives me information about each one of these matches. So it's kind of nice to quickly test stuff. But it also does a lot more than that. It actually explains your regular expression. So it goes through each of these and tells you what each bit is doing. It gives explanation of the modifiers. So you can set all the modifiers here in the website and see how they affect things. And you can imagine if I get more complicated, then there's more and more here, and it kind of says, okay, this is a quantifier and it's greedy and it's doing this. This is white space and it's doing this, and it's saying it 0 times. So especially if you have a regular expression from someone else or in code you're maintaining, this is fantastic. It's just basically explaining step by step what the regular expression means. Also has quick reference at the bottom. If you dig around this, you might, sorry, you might find some of the examples in my talk, because they were really nice examples of things like quantifiers. So it gives you all the most common ones, and if you click on it, it tells you, there you go. It gives you a little example and describes what that thing is doing. Start a string, there you go. So again, you don't need to refer to this talk, you can just use the quick reference in there. You can play around with substituting, so I mentioned that. So if I do regular expression followed by a load of, I'll tell you what, I'll make regular expression uppercase. That's what I want to do. So I've put the reg within a matching group here, and you can see we've got a different highlighting here. Now it's showing me that that's a different group, and over on the right, you can see you've got the full match and the group for each one. I can make a second group here, and you can see the different groups starting to show up. So here, maybe I want to do reg uppercase, and I need to get rid of that first one. And now I've substituted the first part. So I'm basically substituting the entire match, but I'm using $1 to insert whatever was found within this capturing group. So I'm replacing the whole thing with uppercase reg, which is this bit, followed by the second part of the match, which is this bit. So you can play around with that. This is all the stuff you'll be doing in your code, but it just gives you a nice interactive way to write it. And something I knew, just been clicking around on this just minutes before I gave a talk. This is really cool. Code generator just like auto generates code for you, which is awesome. I've never noticed this before, but I might have to start using this. So if you're doing something, you can just quickly copy and paste a whole code chunk. And what's really nice is a regex debugger. And so this takes you through the different steps that the regular expression engine is doing one at a time. And you can see here that there's 3 different matches. This first one was 12 steps, that one is 40 steps. So you can see what it's doing. And I imagine this would be really helpful if you're trying to optimize a regular expression to make it faster, for example, because you can work through things. Finally, you can save your regular expressions if you want to. And I think there's like a library. Let's see if we have any. There you go. Someone's written one to do it faster. And then you can play around with it. So I don't know. I've never really done that, but might be useful. It's an awesome website. Just use that. Forget about my talk. Keep going with the tips. So something just kind of more for code clarity and how robust your code is. When you start writing regular expressions, it's often kind of really comforting to like match as much as you can, basically. You can see your target string there and you just kind of put everything in and start pulling out all the stuff you need. And like this is a perfectly valid regular expression, right? This works beautifully on the string before. We've got the different matches we want. We've got the different matching groups. But maybe we don't actually need all that. This string just has 3 digits in, and that's what we're trying to capture. So we could probably just get away with that. That's much simpler, much easier to read and maintain, and much less likely to break. So just kind of sometimes, especially if your regular expressions are getting long, take a step back and think about whether you really need it to be that long. And if your regular expression is still getting really long and really complicated, think about whether you need to do it in one go. Maybe your code can just do multiple regular expression tests instead of one huge one with loads of logic. And again, the future you will probably thank you for kind of sanitizing your code a little bit and making it easier for you and others to read in the future. So just bear in mind, you don't have to do it all in one shot. And often it's better to do it in multiple. Okay, but you're still writing one long regular expression. But again, there's ways to write this in your code in such a way that it makes it easier for you to read. This idea actually came from a chat on Slack in the code channel. So I'll put the date here so you can, if you're on the SciLifeLab Slack, you can go back and actually read the full conversation because there's some really nice snippets and people weighing in with different bits of advice there. But I think this particular snippet came from Johan, so it's written in Perl. But you can see it's really nice. It's just a regular expression, but we split up each part of a logic onto a different line and put in a code comment explaining why it's there and what it's doing. So this is matching the faster header, and you can kind of see the logic really nicely. This is Perl, so we've used the X modifier to allow him to do this, but there's equivalents in basically every language. Know when not to use a regex. Regular expressions are really powerful. You can do pretty much anything with them, but sometimes there's a better way that's not a regular expression. This is kind of a common meme now on Stack Overflow. If you're bored, check out this link where someone just completely lost their mind after being asked for the like 100th time about how to do a really complicated regular expression matching for XML. And they've just kind of, yeah, just have a read. But if you're doing something like HTML or XML or stuff like this, the chances are very high that there's actually like a library designed for parsing XML, and you should just use that and just not bother trying to make this massive regular expression that's never going to work. So yeah, don't jump straight to it if there's an easier way to go. Also think about whether there's easier ways within the base kind of code library to do what you're trying to do, especially if you have a super simple regular expression. Here, this is a little bit of benchmarking I was doing this morning, just kind of trying not to get too carried away because I was having a bit of fun. Timing how long it took to search for different things. So this is in Python now, and I'm searching the search string ABC to see if the letter A is in there. I've timed it, and it averages about 136 nanoseconds per loop, so per search, which is very, very, very fast. However, if I just did this with kind of Python native, just is A in the string, then it's 20 nanoseconds, which is 7 times faster. Now, the chances are extremely high that you're never going to notice this difference in nanoseconds. But of course, if you're doing matching within nested loops or something like that, then, and you're starting to do really, really large numbers of pattern matching, then this kind of thing can start to make a difference. So just bear in mind that regular expressions are not always the fastest way to do something if it's simple. If you are doing a lot of matches and there's no way to get away from that, then pretty much everything I just said, you should ignore. So if you want to make your regular expression fast, you should probably be basically super specific to try and help out the regular expression engine so it doesn't have to do too many operations to find out whether your search pattern matches or not. So maybe you do want to match quite a lot of things, actually. Maybe you do just want to do one regex call instead of several. And it's good to try and get your search pattern to basically fail as fast as possible on each given line. So the engine can say straight away, okay, that doesn't match. I'm going to not bother looking any further. I'm going to move on to the next line. Being specific with quantifiers is good. So staying, if you know it's only going to be between 1 and 3 characters, say that. Don't just use a star because it's quicker. You can start getting really kind of complicated with things called possessive quantifiers, which I don't really completely understand. And you can also do something similar called unrolling loops, which I also don't really completely understand. But again, it's all to do with limiting the number of different steps that the regular expression engine needs to go through to find your match. So if you're really hitting this as a bottleneck, you can start kind of Googling these terms and start trying to really optimize your expression. This is from this morning when I was just having a bit of fun to see how much difference some of this stuff could actually make. This is a FASTQ file, I think it's off High C or something, but it's just off the SRA. It's about 1 million reads or so. It's about 100 megabytes. And what I want to match here, all the FASTQ headers here for each read has length something, length 50 in this case. And I want to get those numbers. Okay, so sticking to my tips, I should make this as simple as possible, right? So the only time when I have an equal symbol and some digits is this match. So the simplest regex I can think of is just equals and then some digits. And sure enough, that works fine. That gives me my matches. When I ran this, it took just over 2 seconds to run, which is not too bad at all. Gave me about 1 million matches, so not bad. If I go as far the other way as I can kind of imagine and make my regular expression really, really specific. So now I'm saying that the line has to have an @ symbol and SRR, so that I'm skipping those other lines beneath it, which are not the FASTQ headers. And I just happen to know that this is always exactly the same length, these identifiers, so there's exactly 58 characters of something before my 2 digits. This is now 0.8 seconds, so that's quite a significant speed up. And again, if you're doing this a lot of times or on really massive files, this could really start to make a difference. But the important thing here really is to test. Get yourself some test files and actually start playing around with stuff. I thought it was quite interesting at first. I tried using anchors to anchor my regular expression to the start and end of a line because I thought that was more specific. It might be faster, but it was way slower, which I didn't really expect at all. So yeah, don't take my word for it. Just go and have a play and read up a bit and do some testing. Right. Have I got any questions? A few expressions about whether stuff is available in different languages or not. Yeah, like whether POSIX expressions and stuff like this. And I users and things. All right, I'm not going to go into any of that. Anyway, hopefully now all of you reading will feel like this kind of famous XKCD comic. There's an XKCD comic for everything, so I feel like it's kind of mandatory to put this in as a bit of a regular expression superhero. And if you like this comic, I've found that you can even buy the t-shirt for it. So pretty good. And of course, you can go off and start to play with your newfound knowledge. Check out REGEX. I think someone shared this on Slack a while ago. I couldn't remember where I found it from, so thanks, kudos if you were the original person. But yeah, you can do crosswords with, and you have to figure out the different combinations of regular expressions that give the desired matches. With that quite disturbing slide animation, I'd like to say thanks very much for your attention. My name is Phil Ewels. I didn't really introduce myself, but I work at SciLifeLab and at NGI, and you can find me on GitHub and Twitter and the usual kind of links. If anyone has any questions, I will be happy to take them. So I've got a question in Slack from Johan saying, how do you communicate what you're trying to do with the regex to other developers? I guess I would go back to that snippet I had from Johan where you can split things over different lines and add in comments. It's kind of basically chunk up your single regex into different chunks and add code comments explaining what each bit is doing. That's probably the best way I know to make a regular expression as understandable and user-friendly as possible. Yeah, Steiner's pointing out that if you have kind of a regular expression which is kind of very specific and ugly, that matches like kind of what you're looking at, then of course you also open yourself up to the data changing in an unexpected way in the future. And the more specific and longer your regular expression is, the more kind of brittle it is basically to changes in the input data, which may be good or bad depending on your situation. So thinking about the future of how this data may change and how the regular expression, how your code is going to be used, can be important in how you design a regular expression. Any other questions? Cool. Do you want to wrap up, Sarah? I'll hand over.
Cool. Thank you very much, Phil. I guess you'll be around on Slack if there are any more questions.
Yeah.
So thanks for a great talk. Next Coffee and Code will be on October 22nd. And then Linus Östberg from the data center will talk about Kubernetes. After that, since the December slot would fall on the 24th, and I assume people have other engagement at that point, there is just one slot left for giving a presentation this fall, and that's on November 26th. So if you're interested, get in touch. And otherwise, that's it for today. Thank you very much, everyone, for joining us, and see you all next time.